basically the perimeter of the reserve. So the boundary length right here, the sum of all the different boundary lengths, times something called the boundary length modifier. So this term, boundary lengths, is the total perimeter of the reserve, and then the boundary length modifier is how heavily you weight that perimeter. And again, you want to minimize this function. So what this says is you want reserves that have a smaller perimeter, all things considered. And the reason we would want to do this is because a smaller perimeter means a more clustered reserve, means fewer edge effects, and means a reserve with better connectivity generally. So that's why that term's in here. And then the third function that we have is basically what's termed the feature penalty. That's this term right here, which is multiplied by a conservation feature penalization factor, this term. And it's the sum of all of these for all of the different features. So if you think about, we have a given feature target, like we want to protect, say, jaguars. We have a feature penalty if we don't protect jaguars. And the feature penalty is the same for all species. So you have the same feature penalty for not protecting jaguars as you do for not protecting pigeons or something, right? This second part of the term, the conservation feature penalization factor, is how heavily you weight a given feature for penalty for not being met. So you could put a very high weight on jaguars and say if we don't meet our target for conserving jaguars in this reserve, we're going to have a huge penalty, and then that'll greatly increase the objective function. But then if you have a very low penalty for something like pigeons, it doesn't really matter whether or not they're included or not, because it'll be more important to minimize this cost and boundary length factor. So the basic this is basically the end goal of the entire calculation process and reserve design process, is to find a reserve that minimizes this entire term. And that's sensitive, of course, to the boundary length modifier and the conservation feature penalization factors. These are really the two big user inputs that determine what you want the reserve to look like and what your priorities are. We're not going to work with it today, but you can also put maximum costs if you have like an actual hard dollar limit that you can't spend more than this to create the reserve. But we won't work with that at all today. So how does it work? How does it actually work with the objective function? There's something that we'll be working with called the simulated annealing algorithm. And basically, it works by, let's say that you have a series of planning units. So you've got a grid, and each of them has some conservation feature within it that you want to preserve, or maybe it has multiple ones. What it does is it goes and randomly selects one grid square and says, does this increase or decrease my objective function? So let's say it selects this grid square first.